Today, we're going to work on upgrading my SecKit SK-GO. Hello my 3D printing people, and you might have noticed here lately it has been upgrade season around the basement. I have a lot of different machines that I need to get to, including the SecKit SK-GO. Now this is one of the original SK-GO printers, and there was a bit of a maintenance upgrade that came out for it. They called it the SK-GO Squared, but it mainly had to do with the bed and a few other items. I do have the upgraded kit to replace the bed on this one. I have done some modifications on this one myself. We'll go over all of that. But you might be asking yourself, why do we want to watch an upgrade video, especially over a heated bed? Well, there's a couple of reasons, and I wanted to get you introduced into SecKit if you don't know them already, and the kits that they have available. Unfortunately, they no longer offer the SK-GO, but they do have a kit that might help you with your next cube type printer build. And this is the kit that I was most interested in. Ernest has got some of the hard to find parts for building the SK-GO and put them in a kit. In my opinion, this is what really adds value to this printer. And this whole kit ships for $124 USD. On top of that, on the SecKit Wiki, there's a whole list BOM for building an SK-GO printer. But you could use that kit to build any cube printer you like. And it's pretty affordable. Even if you're not building an SK-GO, definitely go check this wiki just for some ideas. There's a lot of great stuff out here. And because I like SecKit and the work that they do, I'm going to show you their newest project, the SK Tank. And I'll leave all this information in the description, of course, but if you haven't seen some of the videos, including the one where it's being sat on while printing, you definitely need to go check them out. This is going to be a great printer kit. It is a little bit pricey, but definitely there's a reason why they call it the Tank. So check the project out. So I think this is a pretty good source for printer information, and those kits are fairly affordable if you're going to self-source your own printer build. I've gotten a lot of use out of my SK-GO. It's a great little machine. And remember, I'm not being paid by SecKit. I just like their stuff. So now let's take a look at the kit we're going to upgrade with, and I'll show you some of the parts that you would get in one of those essential kits. So this is the kit we're mainly dealing with today. It's a 9-point leveling bed. You get this really solid bent frame, a heater, a magnet sheet, and then an aluminum bed. They did upgrade the brackets that they used to hold the bed on. And of course you get all the hardware and springs. Now I did convert my SK-GO over to auto bed leveling, but if you had a bed that you were able to adjust in 9 points like this one, you could get the level pretty much spot on. And that auto bed leveling, that will actually tell you just how level you are. And something that's important to mention about the kit is it comes with thermal fuses. The SK-GO has an AC power heated bed. And it's always a good idea to put a thermal fuse in line with that. These are rated at 130, but if the bed gets out of control, goes over 130, this will stop it. So this is a great safety measure to take. And with that Essentials kit, if you're looking at that, trying to source build one of these printers, you do get both of these top brackets and the one for the X gantry, the cross member. I like this one. You can put a linear rail right on it. It's really light. You get the X and Y stepper mounts, the Z belt tensioner, the metal frame brackets, and that bed bracket, all the bed stuff that I just showed you. And you do get a lot of these corner brackets as well to help you put it together. And as I mentioned before, I did switch my bed out. The stock bed, as you can see right here, is a 2020 aluminum frame. And the L brackets that it's perched on top of the lead screws, of course, but they can introduce just a little bit of wobble. With the new setup, that's going to eliminate that. On the stock set, they did have multi-point leveling. I actually just put mine on standoffs, and I used the ABL to do the compensation. But what I am curious about, how level will the bed be? How level can we get it after we do the upgrade? So first thing, let's just put the sheet on it and do a level. Our level is complete. Now that is a 7-point grid, so 49 total points, and the bed was at 60C. And you can see we're just a little bit all over the map here. we're almost a positive 1 millimeter in 0, 0, and then in the far corner from that one, we're at a negative 0.706. So we've got quite a bit of tilt. So hopefully this bed upgrade is going to get rid of all that. We'll see just how close we can get it. So let's start by removing the old bed. I'll just go ahead and lift this whole frame off the brackets down here. There's just one screw on each side with a T-nut that goes into the bottom of this extrusion. Remember, this is an AC powered bed. Make sure you have it unplugged before you start to do anything on it. And the whole bed just comes off with those two screws. Hence the reason why there was just a little bit of slop in it. And of course it worked, but this is going to be a big improvement. So let's go ahead and unhook the wires. We have our SSR down here. One of the bed wires is on the right side, and then one of the AC hot wires is on the left. We'll go ahead and unplug the bed thermistor, and then the other bed wire is up here on this neutral power lug. Now if the wires are free, the bed should be free. You can probably just slide this down a bit to get it out of the way, and we can pull it through. And we're also going to replace these two brackets. We did get upgraded versions. I think the easiest way is just to remove them off of your linear carriage. But before you pull these brackets, make sure you put a zip tie or something down here around the rail, because that's going to make that carriage loose. And there's a gap down here at the bottom, so it could come off the rail, and you don't want that. Now that they're loose, I'm just going to go ahead and spin the lead screw and pull the whole thing and the trap nut, because I think it's way easier to deal with the trap nuts when they're not on the machine. So let's take the trap nuts off. There's 3 screws on each one in this configuration. And I also do use this adjuster for my Z in-stop. I believe Michael over at Teaching Tech created this for his, but it works really well. So we'll take that off and try to reuse it. Now we've got everything apart, we can go back the other way. You can see how much sturdier the new brackets are versus the original. These should work out a lot better. We can choose to install these brackets whichever way we want. We can put them like this if we have a shorter hot end. I've just got a V6 clone on this one, so this is the way we're going to go. But you can also flip them over to get a little more height if you have something like a volcano. They should work just fine in either configuration. But we're going to go with this way for now. So the lead screw nut, the trap nut, will go on the bottom, and then the bolts will come from the top. And there's just an M3 nut holding it on the back. There's 1 and 2. And on one of these, I'll go ahead and put my end stop bracket back on. There should be more than enough room for it. It goes on the outside just like that. It's for the Z end stop again. That end stop is upside down on the top of the printer. So the one with the end stop, at least on my configuration, will go on this side. And we're just going to assemble these just like we took them off. Now remember, your lead screws on this kit are synchronized with a belt. They run off a 1Z motor. So it might be a little tricky putting these back and getting them synchronized, but you can always pull the belt and adjust them if you need to. It's not too hard to get them lined up actually, because you can just pull the grub screws on either one of these gears down here and get it lined up. If you do it right, when you're putting these brackets back, you might not even have to do it, but definitely give it a look. Maybe try to level it up when you're putting everything back. So I'm going to put these back on the sleds. And now that the brackets are on, you can just set these lead screws in the nut. In fact, turn them the opposite direction. Put a little weight on this side, turn the other side. Let them skip just a bit. And that way you'll know they'll start at the same time. And then just start them. And now they should be just as in sync as they were when you took it apart. But again, it's not too hard to resynchronize those. Now we can go ahead and put the bed together. Pay attention to this mark right here. The folded edges on this actually go up. You can see this aluminum sheet will only go on one way. These holes over here are offset. So make sure you have it lined up on this bed correctly before you go any further. But to help you out, that's where this mark comes in. This is going to be toward the back. Also, it's handy to make a mark on this on the other side, somewhere in this location, just so you remember where the orientation of the bed wires are going to be when you install it. So we can go ahead and put the heater on our bed sheet. There are countersunk screws. They go on the top, of course, so we're going to put our bed heater on the other side. And I'm just going to clean this up with some alcohol before I put it on, just to make sure it sticks well. Remember, again, these two holes are in different locations. So make sure you know which way is the back of the bed before you run your wires. Just line it up with that carriage, make sure all the holes line up, then you'll know. This is the back of the bed. The hole is actually a little bit further to the right of the printer. So this is a standard 300, 400 watt silicone AC powered heater. It just has an adhesive back. So I just like to start peeling it, lay it down on the bed slowly. Of course, we want to make sure it's as center as possible. And then roll it down with something to try to get the air pockets out. I like to use these 3D printed spool holders. They're just barrels and frames that you can print out. The barrels, the top barrels on these, work great for rolling these down. Remember, you only get one shot at this. So I'm just going to get it started here in the front. And we can start rolling it down. And just keep peeling and working the bed onto the plate, little bit by little bit. Again, this is just to make sure that there's no gaps in between the seal and your metal plate. There is a hole in the middle of this heater for that center screw. Make sure that's nice and lined up as well. I should have told you that before we got started. And there we go. I could have got it a little straighter, a little more even around, but it's not going to make too much difference. We should be good. So now for the thermal fuse. Basically, all we have to do to use that fuse is put it in between one of these leads on the bed. It just has to separate that AC connection. So we'll just use this one. We'll put it over here on the side. So what we're going to do is use blade connectors, and we're going to use screws to screw down to this fuse. And all this hardware does come in the kit. But I'm just going to make a loop on both sides of this fuse, just big enough for the screw. So we've got it bent around both of those, just like this. And I'm just going to split this wire and put a blade connector on both sides. And if you can find these larger ring type connectors, even better. These are 4mm screws. But we'll just strip some insulation off and crimp those down, and then we can just put those on either side of this fuse, and we'll hold it all together with a nut. And I want to get those fairly snug, just don't hurt your fuse. And then for extra credit, you can use some thermal paste on your fuse just to make sure that the heat is dissipating enough into the fuse so it reads correctly. It's not mandatory, but it can't hurt. And then we need to tape this thing up many, many times to make sure no hands can get anywhere close to this. This is AC current. And I used about 6 layers of Captain tape. I know it looks horrible, but I want to make sure that nobody gets shocked on this thing. And once you have it all together, it's a good idea to check the resistance across these leads. For a 110 volt bed, it should be right around 30 ohms. For a 220, 121 ohms. But this will let you know that the heater has the proper resistance and that thermal fuse is intact. It's all working. Now we're ready to go ahead and install all the bed leveling screws. So I'm just going to keep it on this side. These are really long countersunk screws. I'm just going to put one in each hole here, and then we'll build up. So there's all 9. Probably a good idea to start with the one in the center. Should have told you that. And then next we'll put an M3 nut on. All those are on. You can go ahead and snug those up. Those won't move at all. There we go. And then the spring goes down on that. And then the whole bed carriage sets down on top of those. Remember, the bent part actually goes up. And that orientation mark that I showed you, that goes towards the wires. So that's the back of the bed. Sets down on it just like this. Then you can put your M4 fender washer on each one of those. And then you can go ahead and put your wing nuts on. This will be how you adjust it. Now, while we're doing this, you don't necessarily have to do this if you have ABL, right? You could put 3 of these on. You could just do a triangle and then let ABL do the rest. I'm actually going to try to do this as an exercise of just how level can I get it. So I have lots of different leveling points here just to see how I do. So you can do it either way. With ABL, the triangle method works just fine. And I'm going to just put these on just so it touches the washer to start, so they're all equal. And then we can adjust it when we do our leveling. And I actually forgot a step. I'm going to take these washers off of these 2 off. But for these 2 that are actually going to go on those brackets that are on the printer frame, there's these nylon tubes that help you line it up. So put those on first, then your washers, then you can put your wing nut on there. That actually does help this process quite a bit. Then I'm just going to bring these L brackets down a little bit so I have some clearance. Wires towards the back. And this whole thing's going to set in here just like that. Those nylon spacers help keep it center in that bracket. Then from the top, I'm going to use some M4x8s. There's 2 on each side. They'll go through the bed and into the L bracket. We'll just put nuts on the underside. I'm just going to put it on loosely for the moment because we're going to have to move it around just a bit. And then we can kind of adjust it depending on where our nozzle is. So there's home. We want to get the most bed area out of it we can. So I'll lift it up a bit so I can judge. So the bed is quite a bit that way. So let's just slide the whole thing towards the right here. And that's about as far as we can go in that direction. So we should be good. There is a screw hole there anyway. And the other thing you need to watch out for is to make sure that there is a gap in between the bed and this front extrusion. This is also a pretty good way to make sure the bed is straight. You can judge how straight it is to the frame. Doesn't have to be a very big gap, but there has to be one or it will collide on taller prints. So that looks pretty straight. I can go ahead and snug up my M4 and put it in place. So the bed has been installed. We can go ahead and wire it back up. I am going to use the protective sleeve from the old bed on my bed wires. This time I have elected to run them through this hole. Definitely use covering. These again are AC wires. And on the bed side, we do have kind of a sharp edge now. Screw that down to something or put a zip tie on it. You just don't want it to move at all. Double and triple check that this is not plugged in. So I'm going to use the wire that we connected the fuse to because now it's just a bit shorter. I'm going to use that down here on the SSR because it's closer. We can go ahead and plug our thermistor back in. And then the other bed wire, again, goes back on the neutral up here on the power supply. And there you go. A couple of zip ties for your wire management, and you'll be ready to start printing. Also, too, if you did have to take off the cover of your SSR, put it back before you plug it in. You don't want any of that exposed. Now all we have to do is clean up a little bit. And we'll put our magnet sticker on. You can tell that this is a whole lot sturdier than the extrusion bed. I'm going to do this one the same way that I did the heater. It should lay just inside the screw pattern so that you can get to all the screws if you ever need to. And I'll just roll it on. Magnet sheets on. We'll put our flexible sheet back on there too. And now we're ready for some more tests. Now when you're doing auto bed leveling and you're trying to figure out just how level your bed is, you're doing something like this, trying to get it perfect, you have a couple of options here. The first one, I recommend just opening up Pronterface, the terminal, and then running your G29, and it's going to spit out a map like this. There's several sites you can go to where you can just copy this mesh and then paste it, and it'll show you what your bed mesh looks like. This is the mesh visualizer over at makedev.co.uk. I like this one. Just paste your mesh in here. This one had a really odd measurement, but you get the point. Now you can see what's going on the bed. This is much easier to correct things if you know what the points actually are. And you can just hover around and it will give you the numbers. But there are also a lot of great Octoprint plugins that make this just a little bit more automated. I've showed you bed level visualizer before, but it's pretty easy to use if you have an Octoprint instance. Here's what my current mesh looks like. There is a little bit of setup involved. Before you use it, you do have to have some start G-code commands, but this will make it just a little bit more automated. It'll heat the bed for you, it'll do all your homing, so it makes it just a little easier to run the sequence. If you need one of these for a specific firmware, you just click up here. It'll take you to the GitHub, and then you can pick what kind of leveling you're doing and what kind of firmware you use. There's stuff for Clipper, Prusa, Marlin, the works. So just copy and paste all of this for your firmware back into the plugin, and you'll be good to go. And you can set any of these settings that you like. So now with this installed, all we have to do is hit Update Mesh. It's going to home everything, heat the bed, do the level, and then report back the map. And here's what we have. As you could probably guess, it is all over the place. But at least we have something we can look at to tell how we need to adjust it. So basically, all I'm going to do is run a bunch of these, go through and adjust all of these thumb screws until it's fairly level. You really wouldn't have to do this. We have auto bed leveling. It's going to be able to take care of most of this, but it never hurts to get it physically level as much as possible. So I'm just going to give it a try. We'll see what we can do. So after about a dozen times around the bed, I got pretty close. We're in hundredths of a millimeter here all the way around. You could probably fiddle around with it all day and get it even closer, but I'm pretty satisfied with that. The 9-point level is working really well. And why not a quick test print? And there we go, our SKGO bed upgrade is now complete. And again, I know this video isn't for everyone. It's probably not really interesting watching me upgrade a heated bed, but I do really like the SecKit company and the things they're working on. Definitely check them out. Also, if you're considering building a cube type printer, something Core XY, this might be a good essentials kit to get you started. I really like this design and it has been a really good machine. Also, if you're going to use a bed that has AC power, a thermal fuse is definitely a good idea, just to keep you just a little bit safer. So hopefully you found this helpful. That's it for today, and I'll see you really soon on the next one.